Hello, this is Joseph Domingo, and here we have digital communications. For this part, we are going to be talking about cryptography. Let's briefly discuss the definitions of cryptography. Cryptography refers to inventing cipher systems, cryptanalysis refers to breaking these cipher systems, encryption is turning plain text to ciphers via encryption, and decryption is turning ciphers to plain text via decryption. There are four main objectives of encryption. First is confidentiality, in which no third party can read the information. Integrity refers to no third party can change the information. Authenticity is where the receiver is assured that the sender sent the message. And non-repudiation is where the sender cannot deny sending the message. Let's now talk about the different kinds of crypto systems. First, we have the pigment cipher, in which it uses weird symbols as ciphers we need to solve. In this case, compare the encrypted messages or symbols to whatever is listed here. So, this symbol represents T, this symbol represents H, this symbol represents I, this symbol represents S, and so on. Next, we have the shift cipher, in which the letters of the alphabet have been shifted 3 times. If you see one of these ciphers, all you need to do is substitute whatever is listed here. So D will be A, G will be D, L will be I, R will be O, W will be T. Next we have the substitution cipher. Just like the shift cipher, find the letters that has been changed and look into the original word. So N will be A, B will be F, G will be L, M will be P, D will be T, and so on. Next, we have the transposition cipher, in which letters are rearranged. In this example, "Hello World" is rearranged to something like this. What they will do now is they will need to rearrange this cipher to the original meaning. Next, we have the Vigenère cipher, in which it is a cipher that uses a polyalphabetic substitution. This is a little bit more complicated than the other ciphers, so let's have an example. A, B, C to Z will be 0, 1, 2 to 25. Our keyword will be hush, which is substituted to 7, 20, 18, 7. Our message will be run now, which is substituted to 17, 20, 13, 13, 14, and 22. We will then turn this into a table, in which the plain text is here, the message turned into their corresponding numbers. We also have the keyword, the encryption rule, and the ciphertext itself. In order to solve for the encrypted letter, you'll then take these two numbers and add them together. Doing that with all other letters will yield us having the encrypted column filled, meaning we can now substitute it with the corresponding ciphertext. If during the addition there is a number that is over the set alphabet numbers, in this case it's 26, you will need to go back to the beginning while continuing the count. Next we have the RSA crypto system, in which this is a public key generation. The steps include choosing two prime numbers, P and Q, compute n, PQ and R equals P minus 1 times by Q minus 1. We will then choose a number E such that it is less than n and relatively prime to R. Find D such that it is relatively prime to R and ED equals 1 mod R. We will then have the public key. Let's have an example. Here we have A, B, C to Z, in which it is converted to 1, 2, 3 to 26. Use P59 and Q equals 79. Choose E equals 5. Our plain text will be sun. What will be the ciphertext? Let's now try computing this. First we have n equals pq, which is 59 times 79, in which the answer will be 4661. We will then have our public key, which is 4661 and 5. Let's now compute for the final cipher of the word sun. Let's start with the letter S, which is denoted by the number 19. It will then become 19 raised to 5 mod 4661. Compute that and we will get 1108. Do that for all of the other letters and we will get the final cipher, which is 1108, 1065, 1809. Next, we have the affine cipher, in which the encryption rule here is AX plus B modulo 26. Let's have an example. Let's say we want to encrypt the word sad. In the alphabet, we have A, B, C to Z. That's converted to 0, 1, 2, 225. Next, we have the key, which is A or B, or A and B, I should say. In A, we can choose whatever number that is listed here. Same thing with the B, we can choose any of the numbers listed, which is the numbers that corresponds to the alphabet. Let's say we want to use the key 7 and 13. Here we have another table in which we have the plain text, X, which is the number corresponding to the letter, the encryption rule, and the ciphertext. We will then need to substitute the numbers we have to the encryption rule, which becomes 7 times 18 plus 13 modulo 26 for letter S, 7 times 0 plus 13 modulo 26 for letter A, and 7 times 3 plus 13 modulo 26 for letter D. Solving this will give us 9 for S, 13 for A, and 8 for D. And looking at the alphabet, this will give us the ciphertext J, N, and I. And that's it. Thank you for listening.